And I'm letting people walk up, but in the meantime, I'm going to start off. First of all, I'm Maggie Levenstein. I'm the director of ICPSR at the Institute for Social Research. And while we wait for you guys to ask questions, I will start off by asking a question which, based on the analysis of the ads that you were just talking about, you were talking about different hypotheses about why ad effects decay, and in the evidence, I know we were all kind of caught up in the campaign, but perhaps you could say something about what you learned from this about why they decay.
Yeah, I would love to, but we haven't done that analysis yet. So really the way, it's, to put this stuff out there every week and write about it in platforms like the New York Times, even though these analyses are very simple, the kind of thing you're going to write about in the newspaper, you don't want to be wrong. And so, and you're doing it every week. So it really does take basically all your bandwidth to do your real job, teach your classes, advise your students, and do this kind of stuff and hit it really hard to make sure that you're telling a story that the evidence is actually telling. So we will get to the long science part of this project now that the election is over, but we haven't done it yet.
Thank you. Do we have?
Hi, I'm Henry Kelly from Michigan, but one of the things that seemed apparent from this election was people getting information from non-traditional sources, and I'm curious about your ability to tell how much of the information they're getting from television ads and how much information they're getting from all these alternative inputs.
Yeah, I would love to hear you guys talk about this too. My sense of this is that that question is very difficult to answer. We can get content data on what's in the legacy news outlets. We can get content data on what's on Facebook and what's on Twitter and I suppose Instagram. We could visually code things like that. The trick, we were saying at dinner last night, is that those data sets are so great, but what we're missing is the dependent variable. And so a little bit, we know whatever those effects are, we know that they're going to be small and they're going to go away pretty fast. And so you can either do you can do some kind of aggregation to the precinct level or something, and but you're really talking about an individual level analysis, which means you need individual level data on this, basically who people's preferences, who they're going to vote for, who they did vote for, and preferably over time, because what you're talking about is an analysis that requires a change in legacy news, a change in advertising, and a change in stuff on Facebook and stuff on Twitter in order to tease out which one of those is driving the individual's vote choice. And that dependent variable, we just don't have. There is not enough, ironically, in this era where we have so much administrative data and other kinds of observational data, we are survey data poor. And if we want to do this, we need more high quality survey data on preferences. But I would love to hear you guys talk about that too.
Well, to some extent, it's an issue of the drunk searching under the light for his keys, because that's where you can actually see. So, we're very good at getting data from sources like Facebook and Twitter and other digital sources where traces are recorded both automatically and manually. We're less good at getting data from television, right? Somebody is sitting in front of the television figuring out what they're watching, although Nielsen and other companies have figured out how to do that. But I think putting it all together is the hard part. So digital data, social media data, television, radio, possibly poster ads that people see, around town. It's quite daunting. It's hard to think about exactly how you would go about that for one person over time, let alone as many as you need to actually do a statistical research of any appreciable degree of power. So, yeah, we've got a work cut out for us, I think.
Hello, I'm Stephanie Teasley from the School of Information. One of the things I really liked about this panel is you're all social scientists, but you obviously use very different methodologies. And in particular, it would seem to me, from listening to Ben and Chris, you guys have some differences of opinion about methodology. Now, am I inferring too much into that, or is that Would you agree with that assessment? Not to, get in a cat fight up there or anything like that, but. Because you were, Chris, or Ben, it seemed to me you were saying more big data, more A/B tests, more machine algorithms, and Chris was saying that can't be the gold standard.
Yeah, so I think that this idea of more big data, I don't think that is the answer, and that's not really what we're doing. It's more about so none of the experiments I showed you I would consider to be big data, right? We're looking at summary statistics. These
If you're
fit in a
running
table.
64 A/B tests continually as one wave and then another 64.
Yeah, and you can,
that's
I can
pretty
write down all these numbers by hand. That's not big data. But the important thing is to be able to basically choose high quality experiments. And so I agree that this idea that just throwing data out there and hoping you can find something from it isn't a good idea.
I agree.
Yeah, and I just think that, picking different photos of, to promote a survey, I mean, that, there's not really any kind of issues with the quality of the pictures. The problem is when we start to infer things, it's more, I think I'm agreeing more with Deen. It's the problem is when we're trying to infer things and we're using automated methods to do that, to what extent are we really measuring that thing? I mean, Facebook has such wonderful outcome variables in that when someone clicks on something, they clicked on it, and that's the end of it. And so that that's a good measure of, and if someone completes a survey, that's a valid measure. So they have that data, and there's really not much debating that is, if that's what they want to predict, then that is what they can predict, and that's what they'll tweak things to do to be able to predict it. It's the issue that I was trying to get at is this idea of inferring things that maybe it isn't quite as clear. Now, we know that people clicked on it because of the fox, but we don't know if they really like the fox more. We just know that for whatever reason, that fox makes people click on the survey. And if that's what we want to solve and that's the goal, then we're doing it.
So again, that's the beauty of this panel. You're talking about different methodologies depending on the questions you're asking and the reasons that you're asking the questions. So I appreciated that. Thank you.
Thank you for the talk. Can you hear me?
No, tilt it down.
So I am Dana. I'm from the marketing department here in the Ross Business School. Most of my research is measuring the dishonest behavior that people usually behaving. And part of the issues that we are handling with is sometimes the people are not willing to disclose activities that are socially undesirable. And some of your talks have directly related to this reliability of data, Deen's talk in particular, but also I think not maybe directly related, but Lynn talks also have some problems, maybe in survey data of people that maybe were not willing to disclose their voting for Trump or something like that was pointed out after the election's result. And I'm interested to hear all of your opinions about what kind of methods can we use using big data, using data science, in order to capture these kind of behaviors that people are not willingly disclosed but can maybe be captured using a lot of modern technology. I'll be happy to hear.
The folks who have done experiments, I think I have this on still. I don't know what happens if you do both, Yeah, it could blow up. To see if there really were the shy Trump voters. There were a couple of survey outlets that did live phone calls, not really randomly assigned, but let's call that what that is, versus an online version of the same survey. So they are doing both. They're not randomly assigning people to mode, but they are conducting both platforms. And a couple different outlets did that, and they found no difference in people's willingness to say that they supported Trump. So I think that shy Trump hypothesis is probably not the explanation for what happened with the polling result. But I'm not sure how I would think about non-survey data to try to, if there were bias, correct those biases.
Well, the way Right, again, yes. Well, the way I think about it is that, you know, when you're using, for example, social media data or any data where people are entering, any social digitally distributed system where people are entering data for others to see, you know, let's say publicly for this example, you have the trade-off where your validity is arguably higher because people are not experiencing the social desirability effect that they might on a survey witness, you know, how uninhibited people can be on Facebook and Twitter, let's just say that. But you make the trade-off with external validity, right? So you can't generalize it. You know, the people that do this, so the people that are willing to engage in these sorts of uninhibited behaviors are a subset of those who hold these beliefs, who themselves represent a subset of all the people who, you know, have these beliefs but may not necessarily be engaging in these platforms. So I do think that it helps you to understand something about the extent to which people feel free to express certain socially undesirable opinions, but you do make that trade-off with external validity because you can't really generalize either the opinions or the modes of expression to any broader populations.
I guess one of the things you could do is if you use, say, Facebook and saw a pattern, oh, it's, you know, brown-haired, brown-eyed women are really expressing a lot of positive sentiment for Trump on Facebook. And then you see in your survey results that you can't find any differences, but you see a difference in this, in sort of these social media data. It would give you some insight into where to go look in your survey data to try to tease out using other variables. Oh, do they align with him on issues? Do they rate him higher on favorability? You know, you could use it as a clue for who these people might be. And then try to tease that out. We don't know which one to hand you.
I have a take on this one. I've done quite a bit of work on online music piracy. Started working on it because we wanted to do something legally which people did illegally. So what we did was we surveyed folks, and you know, lots of other researchers had surveyed folks, and they found that people did not share music illegally. When we looked at the actual behaviors on P2P websites, and we looked at and followed people for more than 2 years at a stretch every hour of the day, the data that we found from their actual behavior patterns versus what they said they did was completely different. So if you can somehow capture their actual behavior pattern like Facebook post, you will probably see something completely different because they are doing something which they are not willing to say, or it's something illegal, and people have found the same thing in terms of drug abuse and other illegal activities.
There is an effort in the survey world to ask respondents when they agree to take a survey whether, you know, I don't know how the question is framed, but whether basically the survey can have access to the data on your Facebook front page, whatever you call that, the landing page. I'm on the American National Election Studies Board, and we talked about this, and I was shocked. Some people have tested this, and how many people say yes to that question. And, you know, like people are just, more people than I thought are willing to say, like, yeah, sure, whatever. Take a look at my Facebook page.
Other questions? I think
I have one question. Yes, and that is one of the aspects that has been addressed perhaps implicitly, but I didn't see it in a high profile, was the issue of coverage and sampling coverage. That in these various testing environments and environments where one is trying to sample a population probabilistically, one needs, of course, a large representative sample and an assurance that you know, stratification of that sample gives you a balanced population, a balanced sample of the population. So I'm wondering if there are any alternatives to using you know, probability sampling methods, using perhaps things like respondent-driven sampling or snowball sampling, also what it's called, or other types of sampling which might use a mix of aggregate population level statistics, I don't know, patterns of going to the movies or purchasing different types of products, and merging those with, say, samples which have been collected on the basis of a dependence respondent-driven approach. And if you think that would bear any fruit in terms of improving the power of your conclusions, I mean, we know, for example, in machine learning that boosting, which is a type of dependency sampling, can improve power with many, many fewer samples than you would need if you were to design a support vector machine classifier using just the standard fixed sample size sampling procedures. So coverage, and whether there are alternative methods or alternative ways to do sampling that can improve the coverage and the power of these types of methodologies that you're talking about.
I think the answer is yes. I think at the end of the day, what's probably going to end up being revealed about polling in 2016 is that the problem was, in some sense, coverage and exchangeability and ignorability.
Yeah.
And, people thought that Republicans in rural areas were exchangeable with Republicans in urban areas. Why? Because typically they have been. But this year they weren't. And so that's now everybody's going to pay attention to that. But I'm of the view that the survey world is still, I think, very much in the probability sampling domain. My view is that we're all engaged in opt-in or respondent-driven samples, because the probability sampling participation rates are so low that everybody's adjusting. And so if you're going to live in that world, I just think more people, more data is always better. But then you're really relying on what you think you know about,
right,
and how to model that to get it to be representative. And so the same mistakes that were made might have been made, but you can imagine if they just allowed a lot of people in Wisconsin to express themselves instead of trying to get 1,000 people who they could make be representative, you might have picked up on the regional variation in a way that would have been instructive to people. I don't know that it really would have changed the ultimate results that were expressed, but it might have made some people at least scratch their heads and say, wait a minute, these counties that are adjacent to Iowa look more like Iowa than Wisconsin.
Good to see you. Sorry, thanks. Hi, Kyle Koiser. I'm with the Institute for Social Research here. I'll just start by saying that I've become a little fatigued by the term big data in general. I mean, it seems a little worn out, but I'm heartened by what I see as maybe a kind of a maturation of the field and the talks and points that you presented in terms of kind of setting up frameworks for characterizing it in terms of accuracy, challenging our models that have been used to kind of digest it. This thought of reiterated experiments as a way to kind of fine tune. And I guess I'd just ask for general comments on where you think the kind of next steps in that maturation are going to go. For example, Deen, I could see, within your framework potentially, do we arrive at a quicker understanding of, for this demographic variable, for this subgroup, what kind of, is there a rule of thumb now for the accuracy of the data that I can glean from different platforms? And I think those kinds of things will lead us, toward a faster deployment and use of the data sources that are out there. And I just ask for your comments on that area.
Yeah, okay. Well, I think in terms of where we're going next, I would like to see, I think as my presentation suggested, more thoughtful I guess, interrogation of exactly what it is that you're looking at. I think a lot of, I don't want to mention any names, but, some research that I've seen has sort of been very, very strong on the methods in terms of the models that have been created and in terms of the scale of the data that has been able to be analyzed, but there hasn't been too much thought about, okay, well, what does this actually mean, right? Does this actually mean what we think that it means? And I think the next step is trying to basically bring closer together the methods that we have access to and what we really want to know. Because a lot of times in research, a good example of this is something like topic modeling, right? So the name itself implies, oh, okay, well, if you just sort of throw this supervised method at this data, then you get a list of topics that, describe on some level what your data are about. Well, that's not exactly what topic modeling does. It's really good at some things, it's not great at other things. And so the name there, I think, can be a bit misleading. So really bringing together the methods that we have, which will, of course, continue to develop in sophistication and in accuracy and validity and all of that, with the questions that we want to answer, which sometimes we may just have to say for some questions, for this particular question, in this particular context, there's just no really good way to answer that for reasons that are not necessarily technical, but that are more philosophical in nature. So a good example of that would be something like sentiment analysis, whereas if you can't get people to agree on what the sentiment is that's being represented in particular messages, then how are you going to get some sort of technical system to do that? So maybe that's just not a great question. And so distinguishing those, I think, will be very important.
Yeah, I just want to add one thing that I see in the future, which I think will be really interesting, is I showed you some results that making things contextual can really give us some big improvements. And right now, we have engineers who have a lot of insight into the field, and they say these are the contexts that I think are important, and we'll run experiments on those. But I think that being able to discover what contexts are important for a certain app, in whatever area you're interested in, is a really exciting idea that I think people will be doing very soon.
So I'm just going to add one thing, which is I think it's come up a couple times here, is that one way to think about what's big data and what's not is a concept which I assume Bob Groves talked about yesterday, and that is what's design data and what's not. And I think one of the things that was really interesting in this presentation is that our Facebook representative which we think of as an example of non-design data, was actually talking about how they use that platform to create designed measures of the things that that are important to them. And what I took your message to be is it's really important to think about how you design your experiments to extract the information that you want. And then the other presentations that we're talking about Twitter and Facebook and using these were also about, well, if you're using naturally occurring or non-design data, how do you do that to make sure that you're extracting the information, that you're measuring the things that you think you want when you're not designing the experiment? So I think that that's sort of one way to bring together the questions that have been coming up. Now, Brian?
Hi, Brian Athey, Medical School in MIDAS. Thanks for the great panel. I just enjoyed it very much. Just changing the nature of the discussion a little bit and moving to education, because I think you guys could really help us understand this, just at the undergrad and the graduate levels. What do you see we have to do to prepare our students to address the challenges that you guys are addressing and is needed in the social sciences? Just in terms of the literacy and the training and the quant bit and all that. I just wonder, that's one. And two, in biomedical science, we are really very much worried about data reproducibility, being able to reproduce the experiment. This has come in huge with clinical research and pharma companies, and NIH now has guidelines. So the first is educational, wisdom you can provide, and the second is thinking about how to reproduce experiments in this age where data is always changing.
Yeah, so actually I'll say something about both of those. I studied engineering and I was not required to take a programming course. And so I learned programming on my own, and that has been the most useful thing I ever learned on my own. So I'll start there. But for the second, this issue of reproducibility is really interesting. And one thing that is a true fact is if you run an experiment today and you run it and there might be a reason why you get different results other than being wrong the first time, right? Populations change, and so you might expect results to change too. And so I think the right way to think about experiments is as like an ongoing process. We tried it today, let's check it again a few years from now and make sure that we're still on track.
To speak to the education bit briefly, I think for the first thing we need to do is we need to decide exactly what it is we want our students to know. So, many years ago there were decisions made, on a disciplinary basis about what statistics each discipline wanted their students to know. So if a PhD, graduate comes on the job market, there is some, assuming they're a quantitative person, there's some assumptions about, with disciplinary wise, about what that student is going to know, right? So they'll know how to do, regression, they'll know what p-values are. So very, very, very basic things. And so we're not anywhere close to that as far as I see it in communication or other disciplines as I understand it. And so understanding and trying to figure out, to make that decision, I think is the first step. And then, there are all sorts of steps that are involved with hiring faculty because, a lot of departments in communication will have one computational person. There are very few that have two. Or more than that, and so you certainly don't want the teaching burden as a practical matter to fall on one person, right? That's a recipe for sort of burnout. And certainly, if you've got somebody who's pre-tenure, which a lot of these folks are, that can be a real burden. So building up a core of professors who can teach this, who can work on curriculum, who can work on the issues of hardware that's needed to process this, software, data access. It takes a lot of investment. I think it takes buy-in from the top to be able to do this. It's not something you can or should do on the cheap, and I certainly hope to see more institutions moving toward this as our data becomes ever more saturated with more and more data.
Mm-hmm. I think just going through a PhD program in communication, you get told what you can't do with data. And that's just a fundamental difference. And I actually appreciate the other side, which is some of the harder sciences, or here's what we can do with data, or here's, all of the ideas that we came up with as graduate students that our advisors shot down were always because we're not really measuring what we think we're measuring, or that the experiment won't come out like we suspect it will. And I'm not saying that that's the right way or that the other way is the right way, but there has to be more critical just kind of assessment of saying that the data is measuring what we say it's going to measure, or this experiment is really, or this data is really the best signal for what we're looking at. I mean, a great critique of what I presented today is, these areas in which we saw more of these anti-vax tweets, right? We can't really generalize that and say that these people are the kinds of people that are spreading these rumors, because that's not what the data is. The data is just saying in these areas there are more kinds of these people, and there's also this talk, and that's really it. And we can't go any further than that. And we just have to, and that's probably the social scientist in me saying, look, you're probably stretching what this data really means as is, and you need to. And so I guess it's probably more mean advisors, right? Just telling people that their ideas suck. So more of that. And no, the data doesn't actually say what you think it says. Is that too pessimistic of an answer?
I'll just add a couple of things. At UCLA, at the undergraduate level, we've done two things that I think have been interesting. We've flipped the classrooms in the intro statistics classes and explicitly told the students why we're doing it. And I think there's been a lot of work showing that if you tell them why you're doing it, it actually amplifies the effect of doing it. And then we've also married the undergraduate statistics class with a substantive politics course. So you can, if you want, take the statistics class alongside your Intro to Comparative Politics or Intro to American Politics class. The faculty members cooperate so that the examples are always things they're reading in the substantive course, blah, blah, blah. So tying the substance to the statistics, which morphs into the things that I think are important for graduate training. And I feel like, I think I have some friends here, but mostly I feel like I'm alone in the wilderness on this. But I'm all for, I can't remember which one of you guys, your Twitter handle says, Python always, R if necessary. Yeah, like, exactly. Like, we are all in our graduate program on all of that now. Like, our quantitative students go get a master's in statistics. They can all write in Python. They can scrape things. Like, they're good at all of that. And I feel like where we're letting them down now, though, is in theory. And I think that's what you're talking about is, what are the expectations about this thing you're about to go do, this analysis you're about to go do? And so much of what's going on now in the social sciences is problem driven. And that's really important. If we want to figure out how to put a waterway in a community in Africa, like that's a problem and we need to solve that, and we are the people to do that. But a lot of the other work in the social sciences is about other things. And I think that we have sacrificed the importance of theory because we've been so busy catching up on the data side, and we have massively sacrificed philosophy of science. And I understand I'm totally in the wilderness on that, but for me, thank you. For me, that would be a required first-year graduate course. How do you know what it is you think you know?
Right.
And that's where I think the two worlds are going to end up coming together and produce some really good magic.
Right, and it plays into the reproducibility thing. I just wonder in your fields, in biomed, we are really being forced to publish and make our data accessible so that others can repeat the experiments, with the data that we accessioned that day and so on. Do you guys have similar requirements in publication?
Definitely.
I think with regarding reproducibility, one issue that I run into personally is that the terms of service of some of the social media systems that we work with actually forbids certain kinds of data sharing. So I'll give you an example of this. Twitter does not allow researchers or anyone to distribute tweet content in ways that are not approved by Twitter. And so practically what that ends up meaning is that you can embed tweets on, say, a web page or something like that, but I couldn't, for example, export a JSON file from a database that has, whatever numbers of tweets that I have on a particular project. What I can do is I can export the IDs of those tweets, which then can be used to reconstitute the actual tweets, provided that they haven't been deleted or suspended or anything of this nature. Now that introduces a couple of issues. One, you have to have the programmatic knowledge to be able to do that. So, it's not that hard, but you have to be comfortable with Python and be able to sort of set it up and get the data in that way, just to be able to obtain it. Secondly, there's data attrition, so it dies off.
Right.
I had a colleague of mine rehydrate a data set of mine that was about 40 million tweets in size a year later. There was about 10% of the data was just gone. So,
Right.
And then over time, the problem gets worse. And so, in many cases where the data are proprietary, or there are terms of service governing how they can be distributed, that can be a major issue there.
Great. Thank you very much. This was an excellent discussion.
Yeah, thank you. I think that actually points out a really important issue, that we need to figure out better ways to share these kinds of very large data sets that are from commercial sources. But we are now actually officially out of time, so I'm going to turn things back over to Al, and thank you all. Thank our speakers, and thank you all for listening.
Separate area that we're working in. Then we've got driver's license that'll link you up to licensing and how many tickets you have. So that looks pretty good the way that I've sort of laid it out. But the fact of the matter is that this is really